If you're really bilingual, wherever you are, whoever you're speaking to, whatever you're doing, both languages are active in your brain. There is no language switch. You can't turn one off.
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. My name is Jesse Lawler. I am your host, and this is the 212th episode of this podcast dedicated to anything and everything that you can do to better help the workings of your own brain. In this episode, we're going to be speaking about something which gets bandied about quite a bit as a great way of helping cognitive performance, making kids and even infants wire up their brains better, helping older people prevent cognitive decline, and presumably doing something for those of us in the middle of those two age ranges as well. I am talking about bilingualism or trilingualism, quadrilingualism, the speaking, reading, writing, listening to any language which is not your native language, something which has actually been pretty well studied. There's certainly no lack of people available to study on this one. And I'm going to be speaking about multilingualism with Dr. Ellen Bialystok, an expert in the field from York University. That'll be in the main interview. And if you hang around until the very end of the episode, in the Ruthless Listener Retention gimmick, I'm going to keep it a little bit language related, talking about some research and some recent findings on how the drug LSD affects the brain's language processing. Stick around for that at the end, but for right now, let's kick things off as usual with This Week in Neuroscience.
Smart Drug Smarts, This Week in Neuroscience.
So we're coming up on the end of the year. It is a natural time to be thinking about habits and routines and how to make next year the best possible. Part of that is always examining the trade-off and what's going to make somebody more cognitively effective, more physically healthy, and of course, free up one's time. And sometimes these concerns are complementary. Sometimes they're actually in conflict with one another. If you spend all your time exercising, you're going to be so busy and so exhausted that you might not have enough time left to do anything mental. But scientists in Canada at Western University have been looking at the opposite end of the exercise duration spectrum, seeing just how low people can go as far as exercise duration and still have measurable benefits to their cognitive performance. Earlier studies have shown cognitive performance benefits in as little as a 20-minute bout of exercise, and this recent study actually slashes it down to just 10 minutes of aerobic activity, after which researchers are still seeing benefits to problem solving and focus. Participants in this study either sat and read a magazine for 10 minutes or did stationary bicycle work at a pretty high level, and then they were given a cognitively demanding eye movement task with their eye movements tracked by computer, says the research supervisor, Professor Matthew Heath. Those who had exercised showed immediate improvement. Their responses were more accurate and their reaction times were up to 50 milliseconds shorter than their pre-exercise values. That may seem minuscule, but it represented a 14% gain in cognitive performance. In their next study, the researchers are hoping to find out how long these cognitive benefits last. And of course, in the exercise cognitive performance limbo of how low can you go, somebody's bound to wonder, well, if 10 minutes helps, what about 5 minutes? My gut instinct here is that if they keep slicing and dicing, even a single push-up, a single jumping jack is probably going to help somewhat. But what the researchers here are excited about is that this study shows that you don't need to commit to a major exercise regime that might not be realistic for all people, says Heath. Some people can't commit to a long-term exercise program because of time or physical incapacity. Our study shows that people can cycle or walk briskly for a short duration, even just once, and get immediate benefits.
Smart Drug Smarts, the podcast so smart, we have smart in our title, twice.
Picked up a couple of 5-star reviews on iTunes. Listener Zool1260 from the USA says, "What a show. I saw this podcast about a month ago and I can't stop listening. Great information. Keep up the good work." And Lizzie McJ from Canada says, "This is probably my favorite podcast. Anyone interested in a very scientific approach to learning about nutrition, their body, and brain should enjoy this." Well, thanks to both of you. Thanks to everybody that's been leaving reviews or otherwise disseminating Smart Drug Smarts out there to the as yet uninitiated. If you've got people on your list that are looking for a low-effort, high-impact New Year's resolution, put together a care package of your favorite Smart Drug Smarts episodes, maybe send them a couple of links. And the search box on the website actually does a pretty good job of identifying different topics. So if there's a topic you remember listening to something about, but you don't know the episode number or a particular guest, search boxes are your friend. Google is your friend. You've got lots of friends online, and Smart Drug Smarts is happy to be one of them. Got an installment of The Brain Breakfast, our online newsletter, coming out in a couple of days. Actually going to be talking about New Year's resolutions in there, both prospective and retrospective. You can get signed up for The Brain Breakfast at smartdrugsmarts.com/newsletter. We'll do our best to keep your inbox chock full of neuroscience news. Also let you know about things going on with the Smart Drug Smarts partner entities, Axon Labs and Vitamunk. If you listen to this, if it's still 2017 as you listen, through the end of the year, we've got a no shipping sale going on over at axonlabs.io. Make an order, ignore those pesky shipping costs if you're within the USA. And the international shipping actually isn't that bad either. You can get in on that over at axonlabs.io. And Vitamonk.com has a really cool promotion that they're going to be starting off the new year with, kicking off on the 1st of January. You can visit Vitamonk.com to find out more, at least within the next couple of days. And if you are on the Brain Breakfast list, you will find out more there soon.
Smart Drug Smarts.
So if you're in the market for a New Year's resolution for 2018, you haven't come up with anything yet, and you are not opposed to something that actually takes a significant amount of work, one perennial favorite, something that's going to make a lot of people's lists, is learning another language, or maybe gaining fluency in a language that you kind of speak, but only enough to ask your way to the bathroom or something. It is pretty much part of the conventional wisdom now that learning extra languages is good for the brain. Obviously carries a lot of social benefits, there's extra people you can talk with, things like that, but also actually has down and dirty advantages in people's actual cognitive hardware. And the reason that we're aware of this at an almost gut level is because of a lot of years of research looking at the brain differences and the ability differences between multilingual and monolingual people. And if you look at the author list on a lot of those research papers, you're going to see one name that is cropping up again and again and again over a number of decades, Dr. Ellen Bialystok, who is a distinguished research professor and also the Walter Gordon Chair in Lifespan Cognitive Development at York University. She's been looking at the multilingual brain in infants and very young children all the way up to very senior citizens, and we're about to have a talk ranging through the science over the course of her career. What we know about multilingualism, where the advantages lie, where the advantages don't lie, what are the pros, are there cons, and do the benefits keep adding up as people continue adding more languages or more proficiency in the languages that they already have? A really interesting topic, and I think one that can apply to everybody. If you're already bilingual, you're going to be giving yourself a cognitive pat on the back. If you're not, you might find yourself inspired to put something else on your to-do list. And if you are a parent or parentally inclined, you might be thinking, maybe an early language training course for the kid might be more important than Little League or piano lessons or whatever else it was you were considering. So, jetzt wir beginnen mit Dr. Ellen Bialystok. That was German, the one language other than English that I've got a little bit of, saying, now we begin with Dr. Ellen Bialystok.
40 years ago, I was just a rather straightforward developmental psychologist interested in language and cognition and how they interact. So I would study things like how learning words and names for things impacted children's conceptual development. And at some point, this led me to an area of research that was becoming pretty popular in the 1970s, examining what was called Metalinguistic Awareness. This is the understanding of language as a system. So understanding language as a formal system, as opposed to what 3 and 4 and 5-year-old kids are basically doing, and that is just learning language. Metalinguistic awareness turned out to be a really important development. For one thing, it's deeply connected to children's acquisition of literacy, of learning to read. And at around the same time, there was a few studies showing that it seemed that bilingual children were getting these ideas about language structure more precociously than monolingual children. And that's an interesting idea, but it wasn't really so surprising. You'd think, well, they speak 2 languages, they're aware that there are 2 languages. So I did a few studies and actually stumbled in the way of science on something that was at first puzzling, but then increasingly interesting. What I realized after doing a number of these studies was it wasn't that bilingual children just had better metalinguistic knowledge. It was that they did better than monolingual children on some kinds of tasks that examined metalinguistic knowledge. And these tasks were consistently ones in which there was conflict. So you ask them to tell you if a sentence is said the right way. Apples grow on trees. Is that said the right way? Yeah, everybody could do it. Apples on trees grow. Is that said the right way? No, that's not said the right way, and everybody could do it. That's the classic metalinguistic question. Do you know that the form matters? But we added another kind of sentence. Apples grow on noses. Is that said the right way? Well, we explained to them it was fine to be silly. They needed to tell us if it was said the right way, and only bilingual kids could do that. So that made it clear to us that whatever it was that bilingual kids were doing differently, it wasn't just that they knew more about language. They were attending to language differently. They were able to say, well, that's pretty ridiculous because apples don't grow on noses, but if they did, that's how you would say it. So that's what started the next phase of my research, in which we examined how bilingual children were developing not metalinguistic concepts, but the ability to resolve conflict, focus attention, and interpret information that had inherently misleading or conflicting signals.
What would another example, I guess a non-linguistic example of something like that be, just to put that in context?
Well, the standard tasks that we ended up using, which to this day we use with adult populations, are very simple perceptual tasks. So you tell the participant, you're going to see a row of arrows on the screen, 5 arrows, and you can use different kinds of stimuli here. And it's a very simple task. All you have to do is there's going to be a button on each side of the screen. You just have to press the button showing which way the middle arrow is facing. Ignore the other 4 arrows. And the other arrows, of course, are either facilitating the right answer by pointing in the same direction, or they're providing conflict to the right answer by pointing in the opposite direction. It's called the flanker task. There may be 7,000 studies in psychology based on it. By using tasks like the flanker task, we and others in many other labs were able to show that these kinds of simple perceptual judgments where there was conflict from irrelevant cues were performed better by bilingual children.
Have you also replicated these studies in people that are learning a second language at an older age? How do they hold up?
Well, so there's 2 parts to that question. One is to look at bilinguals at older ages, so adults and older adults who happen to be bilingual and have been bilingual for a long time.
Right.
And there's a large literature demonstrating that these findings do hold up across the lifespan. But the other question, which is more subtle and in some way more interesting, what if you're just starting to learn another language at an older age? Will any of these kinds of cognitive processing benefits develop later? And there isn't a lot of literature, but there is a little bit. And it seems to me that they do, but to a much smaller extent. So to put it into a simple kind of slogan, the more the better, the longer the better, and the more proficient the better.
And also the earlier the better, right?
And the earlier the better, right. That's the longer the better. So the longer you've been bilingual, the more of your life you've been bilingual, the larger these effects. And the reason is that these are all practice effects, that they work by reshaping brain networks and attention systems over time. It kind of feeds in to this notion of neuroplasticity. Our brains and minds are open to change throughout life, and experience and practice is the fuel for creating these changes. So just as practicing the piano more will make you a better pianist, more practice in terms of time, quality, number of years with bilingualism will also enhance these effects.
This might be a somewhat heretical question, but are there any downsides to becoming multilingual? Any reasons one might not want to?
There's different ways to approach this question. First, is there evidence that there are actual negative outcomes for bilingualism? And there's one, and it's trivial, and that is, on average, bilinguals have a smaller vocabulary in each language than monolinguals. They take longer to process words and sentences than monolinguals. They experience more word-finding problems. These are all reliable effects, but I don't think they're particularly troublesome in real life. Second, there are a lot of studies, mostly with young adults, who use these kinds of tasks that I'm talking about, like the flanker task, and say, well, we took, 2 large groups of monolingual and bilingual young adults. These tend to be undergraduate psychology students. And we gave them a flanker task or something similar, and there was no group difference. Well, that's true. We find that too, because these are very easy tasks and smart young people just all do them really well. But is that a negative? My argument is that to show that something is a negative, you don't have to show that you did an experiment and there was no so-called bilingual advantage. You need to show that there's something cognitively negative, and that has never happened. There is no such study. So all of this research either shows that bilinguals are performing better or the 2 groups are performing the same. Why is that not a disadvantage? That's the third point. Because whatever else happens, bilinguals can speak another language.
Yeah.
And that's pretty good.
How does literacy play in? Because technically you could learn another language to speak it, to hear it, but not to be literate in it. And it seems like probably there may be some differences there. Have those studies been done? Somebody that might have another language for speaking, but not for literacy?
Exactly. It's an important question, and the research is a bit sporadic. It's very profound because, for example, we have in our community many young adults who are perfectly fluent in East Asian languages. Their parents speak them, these kids speak them, and so on. But if they're not sent to, say, Chinese school Saturday mornings, they never learn how to read and write. So they're perfectly bilingual, but only in the oral forms of the language. Is that a different form of bilingualism than one that includes biliteracy? It's not clear. There are a few brain studies that show that the brains are wired slightly different if you also are able to read in Chinese. The other situation also exists. Some people learn different languages only for the sake of prayer or sacred text purposes. So they can read these languages fluently, they recite the words, but they don't have any conversational fluency in them. What's that all about?
Yeah, I imagine like dead language scholars, that would be another instance of that where you might read a text, but there's nobody to speak it with.
Absolutely. The short answer is we don't know. And I think that all of these differences really matter. These are very complex situations. Even the relationship between the two languages, are they similar, overlapping or not, might matter. So none of this is simple and categorical. All of these factors like proficiency, use, how you use it, who else uses it in your environment, can you read it, how prevalent is the written form of the text in your environment, I think it all matters. And it's one of the reasons that this research is very difficult to do. You've got to find a way of accounting for these myriad special circumstances and find what at the core is general and true.
Do you see any additive differences in adding a third or a fourth language, or do the changes that occur happen with a second language and then sort of plateau from a neurological standpoint?
There are a couple of studies that make the case that more languages are better. And these studies tend to be studies with older adults, comparing those who speak 3 languages, 4 languages, and 5 languages. For example, there's a study out of Luxembourg showing this finding that we reported first and others have replicated, that symptoms of Alzheimer's are delayed in bilinguals. They found it was delayed further with each additional language. So quadrilinguals were more delayed than trilinguals and so forth. However, I think we have to be very cautious about interpreting those studies. When we compare two groups in any psychology experiment, we have to assume that as far as possible, these groups are equivalent or similar in everything except the one factor that we're interested in. So when we do a study with monolingual and bilingual young adults, for example, we give them questionnaires about their language experience. We give them nonverbal reasoning tests to make sure they're all just as smart as each other. They all tend to be undergraduate students in the same university. We ask them about their parents' education level and so on and so on and so on, to try to be as sure as possible that the only thing that's different, that's relevant, is that the people in one group go home and speak something other than English. I think that procedure becomes much more difficult when you move from 2 languages into many other languages. A person learns a second language because their parents are immigrants or their home culture community required them to, or so forth. But I think on average, a person learns a third or a fourth or a fifth language because perhaps they're more motivated, they're more talented, they're more intelligent, they're more educated. It's more a matter of choice.
Yeah, it's more of a self-selected group.
It's more self-selected. So I think one has to be careful about interpreting results that show these additional languages increase that benefit. Maybe it does, but we need more controlled studies. And language selection happens when you have 2 languages, but you're in a context, in an environment where it is imperative that you speak only one of them. You're at work and nobody there knows any French. You've got to select very carefully. So the context I think, interacts with a simple judgment of quantity of use. So not only how much you use both languages, but under what conditions, in what environments, in what qualitative way do you use them?
It reminds me of being back in middle school and high school when you would talk a totally different way around your friends than you would around your parents or your teachers, whether that's like self-censoring of profanity or whatever. But sometimes without actually switching languages, you have really different speech patterns, rhythms of speech, and the kind of things that are acceptable to say. I wonder if to what extent that might be a parallel.
So some people have raised this as a kind of an argument. They say, what's so special about being bilingual? Because even monolinguals make selections all the time. You select different words for the same thing, cup or mug. You select different speech style registers. You choose whether to use sarcasm or metaphor. You make these choices all the time. So it's just like being bilingual, right? Well, I think it's not. I think there's something qualitatively and compellingly different about making these selections across two systems. The interesting and completely counterintuitive fact, and I use that word as a scientist, I use that word very carefully, but the evidence here is so overwhelming, I'm prepared to say it's a fact, is this. If you have two languages that you are fluent in, proficient in to some level, if you're really bilingual, then wherever you are, whoever you're speaking to, whatever you're doing, both languages are active in your brain. There is no language switch. You can't turn one off. So the mind of a bilingual is constantly confronted with this critical selection problem that never goes away. This problem, this need to select the language you're actually speaking to your monolingual colleague and resist the intrusions from this other language that is also active in your brain creates an environment, a cognitive and brain environment that has no parallel in monolinguals.
So because you underscored that as being a completely established fact, how do we know that? That does seem deeply counterintuitive, as you mentioned.
Yeah. And, as I always say, if you were going to build a brain, you wouldn't do it that way. You would put in a switch. But the evidence comes from many sources. There's neuroimaging evidence showing which parts of the brain are involved in using each language separately and switching between languages. There's lots of behavioral evidence showing what happens when you ask bilinguals to make judgments about words or sentences in one language that have been designed to include sort of little landmines from the other language. So, for example, you get words in English. I'll just give you a list of words and you'll see them one at a time on a screen. You're an English-French bilingual, and you just say as fast as you can if it's a word or not. This is only in English, nothing else going on here. D-O-G, word or not word. Yeah, P-A-I-N, word or not word. Oops. P-A-I-N. That's a word in French. Now I'm confused. All of that takes several milliseconds, but they're reliable milliseconds that demonstrate that even though you're only thinking about English words, French is bumping up against it. So there's many, many studies like that that make it very clear that you can't turn off the other language.
Earlier in our conversation, you were talking about how the development of vocabulary and the development of basically gaining access to ideas in kids is really related. Those go hand in hand. I'm sure that's true in monolingual as well as bilingual situations. That sounds really interesting as well. And if you've got more to say there, feel free to take that further.
Right. So I'm not willing to go so far as to say that concepts themselves develop differently or better or faster or even slower in bilingual children. There really isn't direct evidence. But cognitive processing does proceed differently. I'll give you an example. This idea of conflict, choosing to focus on information that's relevant without being distracted by information that isn't relevant. And the examples I've already given you are apples grow on noses. It doesn't matter that the meaning of the sentence is silly. Or the example of the line of arrows where the outside arrows are irrelevant. Another example comes from a much more ordinary problem in spatial cognition. We constantly have to figure out what the world looks like to someone else. If I'm sitting across the desk from you, everything is on the opposite side. To locate objects in space, we need to constantly make these kinds of spatial transformations. But these spatial transformations are full of conflict and full of misleading information. So if it's on my right and it's on your left, but it's in front of me, but behind you, and so on, how can I determine where in space something is? That problem of spatial perspective is handled better by bilingual children. Another example is a problem of figuring out who can see what. If we're both sitting across from each other, some things that I can see are invisible to you. Maybe there's a screen in the way, maybe it's behind a box. So I can see it, but you can't. To what extent can you figure out what the relevant cues are to know what the other person sees? So this is a problem of figuring out a perspective from someone else's position. And again, bilingual children do that better. So they're not misled by just the whole array of what they see. They can selectively attend to the cues that are relevant to figure out what you see, where an object is positioned, and so on. So those are the sorts of things that are probably developing a little faster. Kids all figure this out eventually, but they develop a little more precociously in bilingual children who are used to focusing attention and ignoring distracting cues.
It's interesting because that ability to sort of see both sides of something, both metaphorically and also literally, it seems like it has political connotations almost later in life. Have there been any studies looking demographically at multilingual people and how they might fall into camps as far as like being dogmatic or reactionary or open-minded and things like that?
Not that I'm aware of, but it's a really interesting question. I would think that a problem with that, just prima facie, is that bilingualism is often associated with different kinds of cultures, different immigration, and all of these things are strongly determinant of political views as well.
What is it that you're still most curious about in bilingualism? If you were to perform another study today, what would it be?
Well, I'll tell you what I think the big question for now is, and that's the mechanism. What exactly is the neural mechanism that's creating the kinds of cognitive effects we're talking about? One thing we didn't talk about is these studies that are showing deferred onset of symptoms of dementia. This is a powerful set of studies because the actual dollars cost by dementia in public health terms is beyond enormous. So if you can reduce the number of patients who are living with symptoms, you can save millions and possibly billions of dollars in public health. So this has huge consequences. We have lots of evidence now from around the world that bilinguals display these problematic symptoms of dementia at a significantly older age, something like 4 or 5 years later than monolinguals. But crucially, they have the disease. So if you look in their brains, you can see all the traces of Alzheimer's pathology, but they are behaving and functioning normally, which means they can live independently. So somehow they're able to compensate by, I suppose, using other parts of the brain to pick up the slack as the Alzheimer's infected parts become damaged. So my question is what those mechanisms are. If we can figure out exactly what those mechanisms are, we will have a very powerful tool for maintaining cognitive health in our increasingly older adult population. And this translates into enormous dollars.
I've done a couple of episodes with people who have been studying expertise. And of course, the things that nobody likes in the study of expertise, or at least the public never likes, is that it seems like it's very difficult, if not impossible, to get skills in one domain to generally transfer across domains. But it does sound from what you're saying, the cognitive benefits of bilingualism might be one of these rare instances where you really can sort of pick up a global benefit from learning a specific type of task, in this case, a second language.
Exactly. It's an important point. So this transfer literature, which is now very much at the forefront of cognitive psychology, tries to show how if we train somebody enormous amounts of training on some kind of working memory task, are they then better able to perform either a different kind of working memory task or more dramatically, a more general intelligence task. So there are a few studies that are arguing that these effects transfer, but I think that I would take a more conservative approach and say I go along with these studies that argue that the effects, if they transfer at all, it's only to very similar studies. So that's the transfer argument. I don't think transfer is what's going on with bilingualism. I think it's something quite different, and I call it adaptation. What's happening is that the intense and sustained experience of being bilingual, of managing and using and selecting between two languages, rewires brain connectivity. It gives you a different kind of brain. And mostly it doesn't matter until it does. And when it does matter is when other aspects of this brain system are challenged through disease or dementia. And it's at that time that this more robust brain is better positioned to take over. So it doesn't really matter that young adults who are monolingual or bilingual perform the flanker task at the same rate. What matters is that the rewiring of that brain from bilingualism makes it a brain better able to respond when there's a profound challenge.
Smart Drug Smarts.
So thank you very much to Dr. Ellen Bialystok for taking the time for that conversation. Super, super interesting. I love thinking about language. Fair warning, although it doesn't necessarily have anything to do with smart drugs, I suspect that I'll probably have a couple more language episodes coming at you in 2018. Not necessarily multilingual, but I am really interested in how the brain processes language. Language is, of course, probably the defining feature of the human species. We've got these big brains, but a lot of that is probably as a result of a feedback loop because language was so useful, it got even more useful to have a bigger brain to be able to communicate better and better influence our social fellows with. Anyway, more language ruminations coming at you in 2018, and a little more language coming at you, actually, in the Ruthless Listener Retention Gimmick coming up next. I do want to draw a double underline marker under the point that Dr. Bialystok made in that conversation, that maybe the most profound benefit that comes from being multilingual isn't actually what it does for you now, but what it might do for you when you're much, much older. Humans are typically terrible at doing things like saving for retirement or doing anything that's going to incur a cost now, but have a benefit later down the road. But if it's really valid to think of an extra language as cognitively something that lets you get a couple more miles out of your existing set of tires, that is not to be understated. And also, getting an extra language now certainly does incur costs as far as time, mental effort, etc. But there also are obvious short-term benefits, probably meeting some new people, learning some new cultural stuff, picking up some new recipes along the way. So anyway, end of sermon, but for now, let's move on to the Ruthless Listener Retention Gimmick.
Smart Drug Smarts. Ruthless Listener Retention Gimmick.
So a semantic network is a term that's used both in information theory and language processing and by neuroscientists. In all cases, it deals with trying to give a representation of how different ideas relate to one another. Are they synonyms? Are they opposites? Does one idea typically have an effect on the other or is an effect of the other? And quite clearly, semantic networks are something that we have in our brain. There is a physical wetware instantiation of the idea of a semantic network that somehow is stored within our neurons, but the fine-grained details of how semantic networks in the brain are triggered and activated is not something that's terribly well understood yet. Researchers from the University of Kaiserslautern in Germany thought that they might be able to get a little bit more leverage in investigating this problem by looking at the effects of LSD on the brain. LSD, lysergic acid diethylamide, arguably one of the most famous acronyms in the world, famously gives people unusual ideas. If you're feeling generous, you might say fresh insights. If you're feeling not particularly generous, you might say crazy thoughts. But either way, according to Dr. Nilafar Family, it's almost certainly doing something unusual to the brain's semantic networks. And to study this, she took 10 participants and she showed them a series of photos. Some of them were under the effects of LSD, some of them were taking a placebo, and then she switched people 1 week later. So each group would get LSD, each group would get a placebo. They would run the same test each time. There was a 1 week cooling off period between the two tests. As tests go, this test was not particularly challenging. People were shown photos of various objects and situations and asked to name what they saw in the photos. According to Dr. Family, results showed that while LSD does not affect reaction times, people under LSD made more mistakes that were similar in meaning to the pictures that they saw. As an example, somebody might see a picture of a car and say bus or train, implying that the semantic network for the general idea of vehicles had been activated, but maybe activated a bit too much for its own good as far as absolute accuracy was concerned. The effects of LSD on language can result in a cascade of associations that allow quicker access to faraway concepts stored somewhere in the mind. These findings are also relevant for the renewed exploration of psychedelic psychotherapy, which are being developed for depression and other mental illnesses. In follow-on studies, Dr. Family wants to incorporate direct neuroimaging as participants are being tested, giving a clearer idea of just what areas of the brain are affected as this semantic network activation takes place.
Smart Drug Smarts, where we turn information into sound, into bits, into packet data that turns back into bits and sound, and then into neurotransmitters that release funds that release mail-order synthetic chemicals that cross the blood-brain barrier to release augmented performance from your brain.
Okay, so that was it for episode number 212. Final episode of the year. If you enjoyed what we spoke about here, you can find everything related to this episode up online at smartdrugsmarts.com/212. If you missed last week's episode, number 211, I spoke with Dr. Will Vanderveer about his studies along with MAPS, the Multidisciplinary Association for Psychedelic Studies, into the possible therapeutic effects of MDMA as a treatment for post-traumatic stress disorder. They're moving on to phase 3 human trials on that one, so pretty exciting. Also pretty exciting is 2018 coming up right around the corner. Not sure what our kickoff episode for next year is going to be, but you'll find out next Friday if you tune back in. I will see you back here, same time, same podcast, and with that same unwavering commitment to helping you fine-tune the performance of your own brain. Have a great New Year's Eve, a great New Year's. Keep your brain safe, and the ever-important corollary, stay smart.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization. Smart Drug Smarts should be listened to for entertainment purposes only, although some guests on the show are medical doctors, most are not, and the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.